Hello, and welcome to this lesson on calculating the energy change in a reaction using bond energies. In today's lesson, we will learn how to calculate the energy change in a chemical reaction using bond energies. So far, we've discussed how breaking bonds requires energy input, while forming bonds releases energy. Building on this foundation, today's lesson will deepen our understanding by showing us how to quantitatively calculate the energy changes that occur during a chemical reaction. Bond energy is the energy required to break 1 mole of a particular bond in a gas phase substance. Each type of bond has a specific bond energy measured in kilojoules per mole. From the previous lesson, we know that breaking bonds in reactants requires energy input, and forming bonds in products releases energy dot. To find the overall energy change in a reaction, we need to consider both of these processes. First, calculate the total energy needed to break all the bonds in the reactants. Then, calculate the total energy released when bonds are formed in the products. Finally, subtract the total energy released from the total energy needed. We can express this as the formula shown on screen: energy change equals bond energies of reactants minus bond energies of products. Let's work through an example to see this formula in action. Specifically, let's examine the combustion of methane, where methane reacts with oxygen to form carbon dioxide and water. The balanced chemical equation is as follows. It is important to use balanced equations when calculating bond energies to ensure correct calculations. Speaking of bond energies, we are usually provided with them such as in a table like this. To quantify the energy change of this reaction, we first determine the bonds broken and formed in the reaction. The bonds broken in the reaction are on the left-hand side of our chemical equation, and the bonds formed in the reaction are on the right-hand side of our chemical equation. Let's now calculate the energy needed to break the bonds in the reactants. We can calculate methane and oxygen separately. Summing the energy leaves us with a total of 2,648 kilojoules per mole. We now do the same for the energy released when bonds are formed within products. Summing these gives us 3,462 kilojoules per mole. Finally, we calculate delta H, energy change, for the reaction. We can calculate this by subtracting the total energy released forming bonds from total energy needed to break bonds. We are left with negative 814 kilojoules per mole. We have a negative energy change. In chemistry, a negative energy change means that the system loses energy, which is released to the surroundings. Think of it like a bank account. If you have a negative balance change, it means money has been withdrawn. Similarly, a negative energy change means energy has been given out by the reaction. Since energy change is negative, this indicates the reaction releases energy. By following these steps, you can calculate the energy change in any reaction given the bond energies. Let's work through some more examples to consolidate our knowledge. Calculate the energy change for the formation of ammonia from nitrogen and hydrogen. Here is the written balanced equation for this reaction. We can now determine the energy needed to break bonds in the reactants using this table. The sum total energy needed to break the bonds is 945 plus 3 times 436, which equals 2,253 kilojoules per mole. We can also determine the energy needed to form the bonds in the product. There are 6 total bonds, so we need to do 6 times 391, which equals 2,346 kilojoules per mole. We can now calculate energy change for the reaction, and this calculation gives us negative 93 kilojoules per mole. Since the energy change is negative, this reaction releases energy. Calculate the energy change for the decomposition of hydrogen peroxide into water and oxygen. The balanced equation is as follows, and the bond energies are in this table. We can now determine the energy required to break the bonds in the reactants. 4 times 463 plus 2 times 146 equals 2,144. We can also determine the energy needed to form the bonds in the product. 4 times 463 plus 498 equals 2,350. We can now calculate the energy change for the reaction. Subtracting 2,350 from 2,144 gives negative 206 kilojoules per mole. Since the energy change is negative, this reaction releases energy. In today's lesson, we delved into calculating the energy change in a chemical reaction using bond energies. We covered the necessary steps to determine the overall energy change in a reaction, identifying the bonds broken and formed, looking up the bond energies, and calculating the total energy needed to break the bonds versus the total energy released when bonds form. This foundational knowledge is crucial for various applications in chemistry and industry, enhancing our overall comprehension of chemical reactions and their energy changes.